Okay, so I want to add another layer of information to our animation. At this point, if I hit play, I still have some work to do on the animation path, and ultimately I want to go back and revisit this and cause this ball to bounce several times. But for the sake of kind of experimenting with a proof of concept of how to get this thing to work, I'm just going to focus on this simple 4-point animation right now. And in our previous demonstration, we crunched down the timeline. I sped up the animation, so it's actually unfolding over 30 frames. And I might scale that back out here in a minute for the demonstration. I might just leave it as it is. I can also always just change the timeline here and give Cinema 4D only 30 frames of time. So that still accommodates the animation based on the edits that I made to the timeline. So I'm really only looking at 1 second of time. Now, again, that's just really for the sake of this demonstration. When I go back, I'm probably going to trash this whole thing, or maybe keep the assets but get rid of the animation and recreate this so that it bounces several times in time using roughly 90 frames of information. So the thing that I want to look at right now is this concept of squash and stretch. Now, squash and stretch, you can read the definitions of it back inside the Bouncing Ball project if you take a look at the 12 principles of animation and these links that I have here. That'll give you kind of a sort of a textbook explanation of what squash and stretch is. In pretty simple terms, what I'm going to do is, if I go back to my sketch here, and in fact what I'll do is I'll hide the existing layer that I have and create a new layer, and I'll just re-sketch this really quickly. If my ball is starting out up here, and we know the path of the animation is going to go something like that, right? So now as this ball travels down, once it impacts with the ground, if I look at this animation and I scrub the playhead, it's pretty artificial looking, even though the path of the animation looks pretty good. If I were to take something, let's say like, if I wanted to define this as a bowling ball, that might be kind of a bowling ball bouncing across a hard surface. But if I took something like a tennis ball or an orange or something like that, and I were to photograph this over time, we might see something happen when that sphere impacts the ground. What's likely to happen with a soft body object that when it impacts the ground with some force is that it's gonna flatten out a bit. Okay, so that ball's gonna go from being a rounded sphere. When it impacts the ground, it's gonna flatten out a bit, and its volume is gonna shift. It's gonna get wider. It's gonna get shorter, but it's gonna get wider. Okay, and then as that ball bounces back up, it's gonna return to its round form. It'll come back down, and based on the force that it hits with, it'll flatten out again. And so this concept, we can think of this in really simple terms as squash and stretch. So this ball gets squashed as it impacts with the ground. Now, the degree to which it squashes depends on its force and how heavy the object is, and how soft we want to imply this object is. And by adding this squash to the ball, it's really going to help emphasize the animation and add a lot of character to the animation. And in fact, not only are we going to squash the ball, but as the definition implies, there's this notion of squash and stretch. And in fact, that as this ball squashes and it kind of springs back out, it might stretch out. Okay, it'll return back to its round form and kind of travel back down towards the ground, where it squashes back out again. And we're going to use this squash and stretch to really add a lot of character to the animation. And in fact, if you read in the principles of animation, there's also this notion of exaggeration. Okay, so we're kind of double dipping into a couple of the principles here. Relative to the ball impacting the ground, we're going to do this squash and stretch. So we'll squash when it impacts the ground, and we'll stretch as it responds and springs back to its round position. But we're also going to exaggerate that. Okay, we're going to really hit the viewer over the head with this. I mean, when a ball bounces, we'll just do a little thumbnail sketch here. We're going to flatten it out like a pancake. Okay, and now if we flatten it out, I mean, we're going to really exaggerate what that squash looks like, but it's going to happen so fast that it's really going to help imply. It's really going to help us to imply that motion's occurring. Now, there's some really great tools in Cinema 4D to animate, and we'll take a deep dive into some of them. But for the sake of the demonstration, I'm just going to create a new document temporarily. I'm going to create a sphere. And what I'm going to do is I'm going to take a look at deformations. Now, deformations are loads of fun. If I click on this icon here just to the left of lights, these are all the different types of deformations, okay? And if I look in here, there's one called squash and stretch. Now, the way the deformations work, and oh, by the way, if you're using a version earlier than 12.5, you'll find squash and stretch under the character pull-down menu. It's going to be hiding in there somewhere. So if you're using anything earlier than version 12, look under the character menu for this. It's the same thing. It's just bundled under the character tools. So I'm going to introduce squash and stretch. Now, actually, let me undo that for a moment and remind you that if I take a simple deformer like bend, I get this bend deformation box or cage. Now, if I select the deformation and I go modify its attributes, here I'll just take the strength and I'll try to bend it, nothing's happening to that object. That's because the deformation has to be a child of the object that you're trying to deform. So I'm going to drag that bend, I'm going to drag and drop it onto the sphere. When I see that down arrow, that means I'm making it a child, and I'm taking that strength now, and I could take that and now bend that sphere. Okay, that's a simple deformation. We can modify all these attributes, and we'll get some use out of bend as well. I'll just delete that bend object. Now, actually, let me undo that because there's one more thing that I want to talk about, and I'll use bend in order to do that. As I apply the deformation and I really stretch this thing out, you'll notice that in this case, I'll select the sphere. If you look here, we're starting to flatten out the geometry. There's not a whole lot of segmentation in this object, and we're starting to see the geometry. We're starting to see the edge lines. And so if I render this, it's going to flatten it out. So I'm starting to see these hard edges, even though it's trying to smooth the transition. I'm starting to see the geometry of the object, these flat planes. Now, if I want to smooth that out, there's a couple of different ways to do it, and the best way to do it is just to add segmentation to the sphere. So what I want to do is, with the sphere selected, I'm just going to go down here to segmentations, and maybe I'll just double that. So maybe I'll make it 48, and I'll hit return. Now I have twice as many segments, and now I'll render that, and that's much smoother than the previous version. Now, I could also put that in a HyperNurbs and do a number of things to kind of smooth that out, but you know, at the end of the day, this animation is going to be in motion, and I don't need that much detail to it, and I can control the amount of segmentation a little bit easier if I just kind of bump up the animation, in this case, the segmentation manually. Okay, so now there is a price to pay. We have twice as much geometry in that scene now, even though it's a simple sphere. We've bumped up the amount of geometry, therefore our render time is going to go up, and which doesn't seem like a big deal, but over the course of 90 frames, we'll start paying the price for some of these decisions that we make. But that's okay. It'll just take a little bit longer to render this animation. And in this case, we probably wouldn't even notice the difference between, that's just not much geometry. So I'm going to take this bend deformer and I'm going to delete it. And what I want to do is I want to introduce squash and stretch. So I'll go into the deformations menu here and I'll choose squash and stretch. That introduces squash and stretch at 0, 0, 0 in that origin space in the middle of our little world here, which is right where our sphere is. And I'll drag and drop squash and stretch onto the sphere. With squash and stretch selected, I can go down here and look at all the different properties, and the things that I want to focus on are mainly the factor. Okay, so if I bump the squash up and raise that factor beyond 100%, what it's doing is it's stretching. It's really kind of stretching that ball out. If I go in the other direction, it'll flatten it out. I want to stretch it out here for a moment. I have the opportunity to expand and contract it as well. Okay, and if I look in here, there are also the ability to adjust the center, or redistributing, really the weight of that where the weight of that sphere is. So the two things that I'll recommend that you focus on, or the three things that I recommend you focus on for now, when trying to establish this squash and stretch animation, is the center. And again, this is an attribute of squash and stretch. Adjusting the center with these sliders or numerically, and factor. And if you feel that you can get a little bit of leverage out of expand as well, that could be a useful one. So again, I'll delete squash and stretch, and I'll reintroduce it. I'll drag and drop it onto the sphere, and I'm focusing on primarily factor. Wrong one. Primarily factor. Okay, and center. Now, one thing that I want to, we'll integrate this into our animation here during our next presentation, but a couple of things that I want to point out is that in the event that you've moved your sphere, or you've moved your squash and stretch before you dragged one on top of the other, just know that if I take my squash and stretch, and I'll just drag it out here for a moment, if I move that squash and stretch up, I'll deselect it. You can see that squash and stretch is kind of like the bend deformation box, the bounding box or the cage that we had before. If I drop that squash and stretch that exists off of the ball, it's not on the ball, if I drop that into the sphere and I try to adjust the factor, it's basically just moving that ball up and down. It's not really influencing that ball. That squash and stretch has to be registered with the actual sphere, and as I move that down, you can see that it's kind of creating some crazy results. Now that we can animate too, and that could be kind of fun, but the bottom line is just make sure that those two objects are registered together. The easiest way to do this is if I select my sphere, I can see that my coordinates, I've never changed the position of my sphere. It's at 0, 0, 0, or the exact same position with which I created it at. And now that squash and stretch is a child of the sphere, I can just go in and zero out the position value, and what that does is it uses the position of its parent object and basically aligns those two objects together. So just kind of something to keep in mind. We'll apply this animation to our existing animation here during the next presentation.